From the depths of space to the intricacies of the human body, science is all around us. And here at Kuya Josh, I am passionate about exploring it all. Join me on a journey of discovery as we dive into the fascinating world of science and uncover its many secrets. I will take you behind the scenes and into the labs of some of the world's leading scientists as they conduct groundbreaking research and push the boundaries of what's possible. I will also analyze the latest data and research findings and break them down into understandable terms for the everyday person. Whether you're a student looking to ace your science exams or simply someone who is curious about the world around you, Kuya Josh is the place for you. So come with me on this journey of discovery as we explore the mysteries of the universe and unlock the secrets of science. Subscribe to my channel, hit like and the notification bell, and join me on this exciting adventure.
Hello and welcome everyone. Today I'm going to talk about Philosophiæ Naturalis Principia Mathematica, also known as the Principia, and its legacy. This groundbreaking work was written by Sir Isaac Newton and published on July 5, 1687, and it is considered one of the most important works in the history of science. In this video, we'll take a closer look at the Principia and its significance. The Principia is divided into 3 books. The first book deals with the laws of motion and the principles of mechanics. The second book discusses the motion of fluids and the phenomena of waves. The third book is devoted to the study of gravity and the motion of celestial bodies. The Principia is written in Latin and uses mathematical notation extensively. It is highly technical work that requires a strong background in mathematics and physics to fully understand. Now, let's take a look at the laws of motion. Newton's laws of motion are fundamental principles that describe the behavior of objects in motion. The first law, also known as the law of inertia, states that an object at rest will remain at rest, and an object in motion will remain in motion with a constant velocity unless acted upon by an external force. Let's dive deeper into this law and understand its significance. To understand the first law of motion, we first need to know what inertia is. Inertia is the tendency of an object to resist a change in its state of motion. An object with more mass has more inertia and is harder to move. The first law of motion is based on this idea of inertia. The law states that if an object is at rest, it will remain at rest unless acted upon by an external force. Similarly, if an object is in motion, it will continue to move in the same direction with a constant velocity unless acted upon by an external force. This means that an object will maintain its state of motion until something else changes it. Let's look at some examples to understand this law better. Imagine you're in a car that is moving at a constant speed on a straight, flat road. If the car suddenly stops, you will continue to move forward at the same speed, due to the principle of inertia. This is because your body has a tendency to maintain its state of motion, whether at rest or in motion. However, as the car comes to a stop, your body will eventually slow down and come to a stop as well, due to the forces of friction and air resistance acting on your body. Similarly, if the car suddenly accelerates, your body will tend to resist the change in motion, and you will be pushed back into your seat. This is also an example of the first law of motion in action, as your body's state of motion tends to remain unchanged unless acted upon by an external force, such as the force of acceleration provided by the car's engine. Now consider a ball rolling on a flat surface. The ball is in motion, and according to the first law of motion, it will continue to move in the same direction with a constant velocity unless something else acts on it. If you kick the ball, it will change direction and speed. This is because you have applied an external force to the ball, which has changed its state of motion. The first law of motion has significant implications for our understanding of the universe. It helps us explain why objects move the way they do and why they remain at rest when not acted upon. It is the foundation on which the other laws of motion are built. Moreover, the first law of motion is essential in the design of many everyday objects. For instance, seat belts in cars are designed to keep passengers from flying forward in the event of a sudden stop. This is because the first law of motion states that objects in motion tend to remain in motion unless acted upon by an external force. By wearing a seatbelt, passengers are applying an external force that prevents them from continuing to move forward. To sum up, the first law of motion by Isaac Newton states that an object at rest will remain at rest, and an object in motion will continue to move with a constant velocity unless acted upon by an external force. This law is based on the idea of inertia, which is the tendency of an object to resist a change in its state of motion. The first law of motion is significant in our understanding of the universe and the design of many everyday objects. Newton's laws of motion are fundamental principles that describe the behavior of objects in motion. The second law, also known as the law of force and acceleration, relates the force acting on an object to its acceleration. Let's dive deeper into this law and understand its significance. The second law of motion by Isaac Newton states that the acceleration of an object is directly proportional to the force acting on it and inversely proportional to its mass. This law can be expressed mathematically as F equals ma, where F is the force, m is the mass of the object, and a is the acceleration produced by the force. In simpler terms, this law tells us that the more force we apply to an object, the more it will accelerate. Similarly, the more massive the object, the less it will accelerate for the same amount of force applied. Let's look at some examples to understand this law better. Consider two objects, a baseball and a bowling ball. If we apply the same force to both objects, the lighter baseball will accelerate more than the heavier bowling ball. This is because acceleration is inversely proportional to the mass of the object, meaning that objects with less mass will accelerate more for the same force applied. Now let's consider a car moving at a constant speed on a flat road. According to the second law of motion, the net force acting on the car must be zero because there is no acceleration. If we want to increase the speed of the car, we need to apply more force to overcome the force of friction acting against it. The second law of motion has significant implications for our understanding of the universe. It helps us explain how objects move and how we can manipulate their motion. This law is used in the design of many machines, such as cars and airplanes, to calculate the force needed to move them. Moreover, the second law of motion is essential in the study of physics and engineering. It allows us to calculate the force required to move an object and the amount of work done in moving it. This information is crucial in designing machines and predicting their behavior. Although the second law of motion is a fundamental principle in physics, it has some limitations. It assumes that the mass of the object remains constant, which may not be the case in some situations, such as when an object is losing mass due to friction or erosion. Additionally, it assumes that the force acting on an object is constant, which may not be the case in real-life scenarios. To sum up, the second law of motion by Isaac Newton states that the acceleration of an object is directly proportional to the force acting on it and inversely proportional to its mass. This law helps us understand how objects move and how we can manipulate their motion. It has significant implications for the design of machines and the study of physics and engineering. While it has some limitations, the second law of motion remains a fundamental principle in our understanding of the universe. In my next video, I will discuss Newton's third law of motion, the law of universal gravitation. We will look deeper into the most fundamental discovery in the history of science. Science has been one of the greatest gifts to humanity. It has given us the power to explore, understand, and manipulate the world around us in ways that were once thought impossible. Through science, we have discovered the secrets of the universe, from the smallest subatomic particles to the vast expanse of space. We have developed technologies that have transformed our lives, from the light bulb to the internet. And it's not just for scientists. Science belongs to everyone, and we all have a role to play in advancing our understanding of the world. Whether it's through citizen science projects, science communication, or simply staying curious and asking questions, we can all contribute to the incredible story of science. So let us embrace the wonder of science and continue to explore the unknown. Who knows what amazing discoveries and innovations await us in the future? Thank you for joining me on this journey of discovery. If you have any questions or suggestions, please let me know in the comments section below. See you in my next video. Good luck!